Alright, let's go ahead and start on infinite limits. So, it tells you for the beginning that you want to use a graph to help you with the following limits. So we're going to start by graphing exactly what these things would look like. So, what we have for the first one is we have 5. So it's just a plain 5, which means it's actually just a horizontal line at 5. And then we'll do it in red. Alright, so as we approach infinity, that means as we move to the right, where is this function going? The answer would have to be 5 because it's not moving up or down anywhere, just staying at 5. Okay? Now for letter B, we're going to go ahead and draw ourselves a coordinate plane. And then this is what's called a reciprocal function. So because it's a reciprocal function, we have asymptotes. And our asymptotes for this one are located right on the axes. So that's the y-axis. And then the x-axis. And then this one is the one that I always remember, kind of like a boomerang. So for a boomerang, it would look like this. Always in the right top and left bottom, unless your numerator is negative, in which case they flip. But as we go out towards infinity to the right, we're headed to our asymptote, which is 0. Okay? Now we're going to do the same exact thing for letter C, except our asymptotes have moved. So our asymptotes have moved. One of them has moved to the right. And then our other asymptote has moved up. And then we will again do our shapes, which are the boomerang. Numerator is positive, so it's going to be right top and left bottom. Okay, so as we approach infinity, that's to the right, it's approaching its asymptote. So its asymptote is 3. Okay, so the conclusion that we want to make here is that if you have the limit as x approaches positive or negative infinity, and you have a number over x to any other number, okay, so these are both just stand for any number, any number, then the limit will equal 0. Okay, so any number on top of x to any number is going to be 0. Now we're going to use that idea here in example 2. It says divide every term in the rational expression by the highest power of x that appears in the denominator. So what we're going to do is we're going to rewrite, and we're going to keep the limit notation since x is staying. Limit as x approaches infinity of 2x squared minus 10x, and we're going to divide, and then we have x squared divided by minus 8x divided by plus 15 divided by. So what we want to divide by is the highest power, that's right here, so x squared. X squared, x squared, x squared, all throughout. The next step is just to simplify. So our goal is hopefully to get us to something that looks like a number over x to the something. Okay? So for the first one, when we simplify, we're going to get the limit as x approaches infinity of 2, because 2x squared divided by x squared is 2. Then we have 10x over x squared, that's minus 10 over x. And then we have 1 minus 8 over x. And the last term can't change at all, there's no simplifying. Okay, so now we're just going to use that rule. We said that if it was a number over x to any number, it's 0. So as we apply the limit, we drop the limit notation. The limit as x approaches infinity of 2 is 2. And then we have minus 0. And then we have 1 minus 0 plus 0, which gives us a limit of 2. Alright, now we're going to do the same exact thing for letter B. So it's going to say the limit as, I'll do it in black like the last one. So the limit as x approaches infinity of x over plus 3 over, and then x squared over plus 4x plus 5. And then the highest power in the denominator is x squared. So x squared, x squared. So what we do is we have the limit as x approaches infinity. And then what we're doing is we're going to go through and we're going to simplify. So 1 over x plus 3 over x squared. 1 plus 4 over x plus 5 over x squared. So what we have is it seems that we have 0 plus 0 over 1 plus 0 plus 0. One thing you want to be sure of is we actually do need to do the bottom because you can't have 0 over 0. When you have 0 over 0, that's something that you should have simplified. But luckily we have 0 over 1, which is just equal to 0. Okay, now we're going to do the same exact thing in the last one. So we're going to do, we need to have black, and that's going to go the limit as x approaches infinity of x squared minus 4x minus 3 all over x over minus 2 over. Now we're going to go through and do the dividing part. The highest power is x in the denominator. So we're going to have the limit as x approaches infinity of x minus 4 over x. Oh, I'm sorry, minus just 4. Let me erase that. Minus 4 minus 0 over 1 minus 0. So here we have the limit as x approaches infinity of x minus 4. So what you would do normally is you would just substitute. So we have basically infinity minus 4. Infinity is infinitely big, so if you subtract 4, technically it's still infinitely big, so the answer would be infinity. Okay? Now what we're trying to do here is we're actually trying to come up with a pattern. So if we have powers that are the same top and bottom, this is something you might remember from Algebra 2. So if the powers are the same on the top and bottom, it's just the ratio of the leading coefficients. That's where we get 2 from. 2 over 1. And then we have bottom heavy. So if it's bottom heavy, meaning the degree is higher in the denominator, then the answer is 0. And then for letter C, if it's higher in the top, then you have either positive or negative infinity. So we're going to go through and write that down here. So we said same means ratio of the leading coefficients Okay, if the degree of the numerator is less than the degree of the denominator, this is one that I would call bottom heavy. And the answer is always 0. And then degree is bigger, this one is called top heavy, or this is what I like to call top heavy. And what it'll be is it'll either be positive or negative infinity. And I'll go through and explain to you how you do those. Okay? So now we'll move on to our examples. So our examples, what we're going to do is we're going to label them first. So this one is top heavy, because you notice that you have negative 2x to the 4th and you have x. Okay? This one seems to be equal. This one is balanced. They're equal, top and bottom. Okay. We'll leave C because we haven't done any like that, so I'll describe that to you in a second. This one is bottom heavy. This one is top-heavy. Alright, and then for letter F, it looks like this one is also top-heavy. Alright, and then letter G we'll leave alone, and letter H we'll leave alone, because we'll have to discuss those. So for all of our top-heavy ones, this is kind of a fancy way of doing it, or not really fancy, but the only places that you need to focus are on the leading coefficients. So we're going to basically not look at these at all. So now we're going to go through and we're just going to plug in infinity, and we're going to decide on the signs that they should remain. So what we should notice is that our coefficient for x to the fourth is negative. So we're going to write negative times, and then if I plug in infinity, so positive infinity, and I do it to the fourth power, it's going to remain positive. Now for the denominator, it looks like we have just a 1 as the coefficient. So we're going to put positive. And then we're going to just plug in positive infinity, which is positive. Then I have negative infinity, or sorry, negative times positive over positive times positive, which should get us negative infinity. Okay, now we're going to find the other top-heavy ones. So I have right here x cubed, and I have right here 2x squared. Those are the leading pieces, the highest exponent. So now we're going to do the same. So 1 is just positive in front of x cubed. If I cube negative infinity, odd powers remain the sign that they are, so negative. And then I have positive 2. And then I have negative infinity squared. Squared would turn this to a positive. So my answer would be negative infinity. Okay, now we'll do the second, or the third top-heavy one. So we have to the fourth and 2x, and we have negative infinity. So I have a negative 3 in front, so that becomes negative. When I do negative infinity to the fourth power, it turns positive. And I have a positive 2, and then I have a negative infinity. So we end up with positive infinity. Okay? Perfect. Now we'll do letter B, because letter B is a pretty easy one. So letter B, we just do the ratio of the leading coefficients, which is negative 2/6, which becomes negative 1/3. Okay? Now, something really, really big when we get to letter C, G, and H. So, C, G, and H, what you want to do is you want to make sure you focus only on the leading ones. And then something you're going to have to do is actually take the square root of your bottom. So what happens is you have 4x squared over x squared. Now, when you take the square root, you always, always, always must put absolute value bars. So when you take, I'll write right here, when you take even roots, you must use absolute value bars. Alright, so now what we're going to talk about is basically when you have powers that are the same. So letter C has powers that are the same. So usually, like in letter B, you would literally just take the leading coefficients. And normally, for most of these examples, you will, even when you do the root. However, one thing that you have to be careful with is, for letter B, you would see that these match identically. So you would say x cubed and x cubed are identical, so really they'd cross each other out no matter what kind of infinity you would put there. However, for letter C, it would matter what you put there, whether it's positive or negative infinity, because whatever's left here, one of them is going positive on the bottom, but the top isn't necessarily positive. So what we're going to say is when we take infinity and we square it, that gets us positive infinity squared. If I take infinity and I square it, I get positive infinity squared. So these do match perfectly. So my final answer is going to be 4 here. But there are times where they don't match, and we'll get to those. But let's look at the next one. So for letter G, it's the same sort of idea, so let's do the same. So, again, only focus on the leading, and we'll have 2x squared over the absolute value of x squared. Now if I plug in negative infinity this time, so if I plug in negative infinity up top, since it's squared, it would be positive infinity squared. When I plug in negative infinity to the bottom, it would be positive infinity squared. Those are identical. They cancel each other out. The answer is 2. Now, when we do it for letter H, remember, only focus on leading. It would go 2x over the absolute value of x. So when I do this one, negative infinity is on top. It stays negative infinity. But if I put negative infinity in absolute value bars, it would turn positive. So I have negative over positive, and then I have the 2. So that gives me a negative 2. That's my answer. Okay? Now, the only one we've missed so far is the bottom heavy one, but those are my favorite because you just write 0. Okay? Now we have just one other section. So it says, find each limit at infinity and explain your reasoning. So, when we're looking at this, we have a polynomial, and if we were to FOIL it out, our highest degree, or our degree, would be x to the 4th. And then it would go blah, 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 blah. So you'd have lots of different things. So you would have different terms that you would place there. Actually, I'll erase that because that's going to look almost like my graph. But this will be an x to the 4th because I have squared, and they're being multiplied. So when it's x to the 4th, and it's positive, notice we have no negative leading coefficients. The picture of that would look like this. Because if I draw a horizontal line, I would end up with 4 zeros. There's a possibility of having 4 zeros. So what we're going to do now is we're going to describe it. It asks you for the limit as x approaches infinity. So I can see based on this one, because they're both going up, that my answer is going to be positive infinity. It wants you to explain your reasoning. So we have this picture here, but what I can say is that the limit as x approaches infinity is infinity because it's an even function. That's where the x to the 4th comes from. An even function with a positive leading coefficient. Now, I would be okay if you don't know all of these terms. I mean, you should know them, but I don't mind if you say something like, it's going up on both sides because it's x to the 4th and it's positive. That would be fine. Now we're going to look at the next one. So the next one is a cubic function. Cubic functions look like this, or have an end behavior of those. So from left to right, they're going up. They're odd, which means going opposite direction, so it goes from bottom to top. So what we're going to say here is that the limit as x approaches negative infinity, so as we look to the left, it's negative infinity because it's going down on the left. Okay? Alright, now for the next one. So the next one, I don't think that I would really want to go through and actually graph that. That seems terrible. So instead, what I'm going to do is do exactly what we were doing in our notes. So, the limit is, and then I want you to look at it for a second. The limit is 3 because the degree on top the degree on the bottom. So we look at the ratio of, of the leading coefficients. Okay, now for the next one's even easier. So the limit is 0 because it's bottom heavy. All right, and that's all.